Hi, I'm Jesse with Mastercam, and in this video we're going to talk about how the combination of Mastercam's accelerated finishing and the advanced 5-axis motion control of the Haas Next Generation Control can help you get an amazing finish in a fraction of the time. When it comes to finishing complex 3D surfaces, ball end mills have been the tool of choice for a long time. The main issue with ball end mills is managing cusp height. Whenever you cut with a tool that has a full circle radius like a ball end mill, a small amount of material is left between each pass of the tool, which is the cusp. Since the key to a good surface finish is to have the smallest cusp possible, that means either cutting with a much smaller step over, which drives up cycle time, or cutting with a larger diameter tool. The problem is, moving to a larger tool isn't always an option. There are many places where a larger tool can't be used simply because it won't fit into an area a smaller tool would. Also, a tool size might be limited for machines with a smaller or less powerful spindle. Well, this is where circle segment tooling can give you the best of both worlds. This Amugi oval form is only 10 millimeters in diameter, but it has a cutting radius of 85 millimeters. That's a massive effective cutting radius, which means you need fewer stepovers to finish a surface. This also gives you a much more consistent chip load over a ball end mill with the same size shank. One thing to note is that depending on part geometry, circle segment tools can induce more 5-axis motion at the machine tool. So you'll see the best performance on 5-axis machines that have more advanced motion controls, like this UMC. It's also important to note that your CAM software is going to need to support circle segment tool definitions as well. Mastercam includes support through our accelerated finishing, which is a combination of the various circle segment tool profiles and advanced toolpath technology that allows you to use these tools with any of our multi-axis toolpaths. Mastercam's accelerated finishing also supports multiple drive surfaces within the same toolpath. Let's look at an example. Here we have an existing multi-axis morph toolpath that's using a ball end mill to finish this long outside face on a mold core. We'll right-click and drag to create a copy of the toolpath that we can modify with our new tool type. On the tool page, in the parameters, we'll right-click and choose to create a new tool. In the Define Tool dialog, we'll see that there is a section for accelerated finishing tools. We can simply select the tool profile we need and then enter the necessary values to define the tool. Another and more preferable option is to visit the Tech Exchange at mastercam.com. The Tech Exchange contains a number of resources like posts, tool libraries, example files, and more. Once you've logged in with your Mastercam account, click on the Tool Libraries tab. You can then search for specific keywords like circle segment, and the list of tool libraries will be filtered automatically. As we can see, there are several libraries available for circle segment tools, but the one we need is for Amugi. Once the library has downloaded, we'll switch back over to Mastercam, and from the tool page in the toolpath parameters, we'll right-click and choose Tool Manager. Let's open the library we just downloaded, locate the oval form tool we need, and transfer that to the part library. Once we've selected the tool on the tool page, let's move over to the holder page. We'll right-click and add a new holder. Because this part is being cut on our UMC 750, we'll choose Cat 40 to match the spindle in the machine. Now let's add and adjust the segments to match the ShrinkFit ER32 holder combo we're using in the machine. Lastly, we need to set the projection length. One way we could do this is by typing in the projection value that physically matches the tool as it's set in the machine. Let's use 1.75 inches. Now we're ready to move to the cut pattern page and begin setting up the rest of this toolpath. Remember, the point of using a circle segment tool is to use the large cutting radius of the tool to minimize the cusps. Because this tool has such a massive radius, we can take our step over value and triple it. Now let's look at the toolpath and backplot. What we're seeing is that the tool is contacting the part near the small tip radius, which will not improve surface finish over a ball end mill. This tool needs to be tilted so that the larger radius is in contact with the part. One thing you'll notice when programming for an accelerated finishing tool is that unlike a ball end mill, there's a much smaller range of tilt that the tool needs to stay within to be properly engaged with material. Let's go back into the toolpath parameters, and on the tool axis control page, we'll change the side tilt angle from 50 to 78 degrees. Remember, 0 degrees means the tool is normal to the surface at the point of contact, so the larger the value we put in, the further the tool will tilt relative to the surface normal. Let's regenerate the toolpath and take another look at it in Backplot. Now we can see that the tool is engaged with the material along that large radius. This is going to result in a lower cusp height even with 3 times the step over of the ball end mill. That's going to provide a much better finish with a much shorter cycle time. After 5 minutes of cutting with the ball end mill, you can see that we are only about a quarter of the way down the surface. The finish looks good, but it's taking a long time to achieve. Now let's run the accelerated finishing toolpath. Note how responsive the rotaries are and how smooth the motion control is. Having a modern control with good motion control like the Haas NextGen is a key part of what makes these tools shine. The tool has only made a few passes and we're already at the same point that we were with the ball end mill after 5 minutes. While a 2/3 decrease in cycle time is impressive, there's also an increase in surface finish quality as well. Both finishes likely meet the specification for the surface finish on this part, but the ball end mill finish is a little fuzzy and will most likely require some hand polishing to really finish it off. On the other hand, the surface from the accelerated finishing tool is already a mirror finish right out of the machine thanks to the larger contact diameter. We hope that you've had a chance to see that on the right part and the right surfaces, accelerated finishing with circle segment tools and a high quality motion control like the Haas NextGen can make a massive difference.